Is it on? Is it on? Let's see. I just finished this thing. Hi. Can you guys hear me? Let's do test here first. I just want to ask, is the music too loud in the back? Can you hear me well? Just like try to do some adjustments. So I guess we have 9 people. Hello everyone. My name is Daniel. I'm one of the engineers here at Balena, and good acoustics. Cool, thank you. And can you hear the music? I don't know if maybe it's just a bit loud for me. Let me just lower it a little bit. Cool. The whole idea of the project today that I want to build with you guys is a balena. We call it balenaPlant. It's a planter. It's a little bit of automation system that we can use to water plants when we go traveling. It's a project that I started, me and Chris, another hardware hacker here at Balena, and we started together and then decided to just build live for those who'd like to watch, just some geeking out. There's nothing, I don't want to do anything too complex. If you guys have any questions, I'm more than happy to help and try to answer if I can. And let's build things together. I think that's the whole idea of what I want to do today. So let's start. Let me just change the camera. I have here a Raspberry Pi 2 that I'm just going to use for development. It's also connected through Ethernet here. The goal of this project in the end is to use a Raspberry Pi Zero, such as this one here. But because the hardware is a bit slow, I decided to let's develop everything. I'll do all the prototyping with like a Raspberry Pi 2, 3. And then once everything's ready, we would move to the Pi Zero, right? So that's the main idea. Okay. So what's the problem that we have, especially in summer? You travel, and then I wouldn't say the biggest problem, but a problem of like householders is that when you go traveling, your plant needs water. There are a lot of DIY methods that usually doesn't work. I try many of them, such as like having a string attached to the plant, and this string is in a bucket of water, and then because of capillarity, it pulls the water into the plant, and then, yes, like Alexa said, and then the plant is dead, right? That's what happens a lot. So okay, why not? So it's a fun project that we decided to build, and it turns out pretty okay. So I decided to do this live and see what happens. For this, what we're gonna need is a moisture sensor. I'm gonna show here. Let's change the camera. This is a capacitive moisture sensor. What it does is that when it's in the water, it changes the capacitance, and then there is our electronic circuit here that turns the voltage into an analog signal, and then we can read that in our microcontroller, or in our case the Raspberry Pi. Quick trick that I learned doing this project. The problem with this board is that it's not waterproof, at least the electronics part, and the solution that I turned in the end was just to use some nail polish, and then it works pretty well, and it actually looks pretty nice. Let's see if I can focus. So yeah, this is the electronics here. This board works, for example, like 3 volts and then an analog pin out. After this, I'm just gonna put here, we also are using a DHT22 temperature and humidity sensor. This one, it's pretty good sensor, it's pretty accurate, and I really like working with it, so I decided to choose this one as well. Another thing that we're gonna use is this. It's just a switch. It's a float switch that you can just put this in the water, and when it's all the way down, it means there's no water. As soon as you put inside the water tank, it goes up and closes the switch. So this is like a let's say a binary switch, just 1, 0. Then you can use that to build whatever you want. Then let's see what else. I decided to also choose the automation hat from Pimoroni because it has a lot of things that we need for this project in this board. It works perfectly with the Raspberry Pi. It comes with 3 analog digital converters. In this project, we're just gonna be using one, but if you want, for example, measure the soil of a few plants, you can use up to 3. Also, it has a relay that we're gonna be using to control the pump. And then some extra inputs and outputs that we're going to use. And one of the cool things else that we're going to use in this is just this pump. You can buy this from Adafruit. It's a 12 volt water pump. So you just put power and then you start pumping water or whatever you want. And this is we're gonna put one side in the water tank and then one to the plant, and then whenever the moisture sensor is too low, it's going to water the plant, right? It's pretty straightforward. And then on the balena side, we can monitor everything that's happening with the plant. We can also check the moisture. We install some Grafana charts that we can follow what's the temperature, humidity of the soil, when was the last time the pump was turned on, and so on. Before I dive into the code part, I'm going to work on the electronics. So first things first, if you have any questions, please go ahead and ask me, because I'm just going to be nerding out here. Let's see. First thing I'm going to do is connect the Raspberry Pi hat to the board. Pretty easy. Small detail is that the Raspberry Pi works on he has a 5 volt and a 3.3 volt output, and I tested for the pump. It works pretty well with the 5 volt. It doesn't necessarily need to go 12 volts. It just it's a DC engine, DC motor. So the main difference I would say is just the power, the speed, right? So that's gonna work as well. Let's go ahead and do the rest. Do you guys have any idea? Any questions so far? I think everything's good, right? Nothing's too complex. I'm going to move my camera so you guys can see a bit better what's happening here. Let's see here. Sorry, I'm just figure out the best way to do this. Yes. Then let's start with the temperature and humidity sensor. The thing is, this one uses. I'm going to use a 3.3 volt. Let me just move the microphone a little bit closer. I'm going to use a 3.3 volt. I need to connect this to the ground. And the thing is, it's a digital signal for the Raspberry Pi. So what I'm gonna do here, actually, in my previous test, I can just use the clock pin on the automation hat, which it's gonna go directly to the GPIO pins of the Raspberry Pi. Because one issue that I had before was that I was trying to use the buffered input, and because it's like it's a digital signal, it wasn't transferring all the information correctly. So then the solution was to just put directly to one of the GPIO pins, which we could use one of these pins, but then just using the side ones, it was a bit easier. So let's just do that. I'm gonna turn on here my soldering iron. And also this temperature and humidity sensor was made to be used with the Seed Studio hat, the one that has a lot of these connectors. It was called the I forgot the name right now, but then because I didn't have these connectors on this board, I did decide to do some jumpers, and in the end it worked pretty fine. Same thing goes with the temperature and humidity sensor, which I'm gonna connect a 3-volt, a ground, and also a signal pin. The signal pin is gonna be one of the analog to digital converters here. So let's go ahead. So the trick of this, the prototype, let's say, right? It's where you just hack everything together to make it work, and then let's say in the end it becomes a true final project, and you redo everything properly. So the way I'm going to do this, let's find out if it's going to work. I'm just going to, I already have some solders. Aha. So it looks okay. So this way I'm giving 3.3 volts to the humidity sensor and the soil sensor. Now I need to do the same thing with the ground signal. Just take this out. Let's see if we can connect this easily. Always trying to make sure you don't short circuit anything. Let's see, it looks good. So here I have the two sensors connected the power to the 3.3 volts and the sensors to the ground volt as well, ground plane. And now it's the easy part. So for the soil sensor, I'll just move this a little bit further away, I guess it can help a little bit. Improve the focus, okay. So for the soil sensors, because it is a analog signal, I can just connect to the ADC of the board, which, let me get the screwdriver. This is the one, yes. I'm going to connect to the pin 1 here and give it a good screw. Okay. Oh, good. And then for the DHT sensor, I'm just going to connect on the GPIO pin here. There's not a lot of soldering to need to be done here, but I decided just looks better and it's more secure. All right, so if you can see in the other, let's check the bigger camera now. How's everything here? Let's see if it's gonna focus. So you have the two sensors connected to the power, the ground. The DHT sensor is connected directly to the GPIO pin, and then the moisture sensor to an ADC pin. All right, now we can move to the next part of the electronics before diving into the code. I don't know which part you guys are more comfortable with. I like more electronics, but I love code as well. I'd say I'm a kind of true geek. Let's go with let's work with this. Just change the camera here with the water flow sensor. So the way it works is pretty straightforward. It's just a switch. It's on and off depending if it's up or down. So for this, what I'm going to do is I'm going to use the buffered inputs from the automation hat, and in the other side I just put a 5-volt pin. So that's pretty straightforward. All I need to do, you have a 5-volt output here. I'm just going to screw this. And then I'm just going to use input number 1. So that what it does is, if this circuit is closed, in the input number 1 it's going to read 5 volts. If it's not, it's going to read nothing, right? All right, what else are we missing here? We are missing the pump, right? The pump's the most fun part. Can you guys hear me well? I just don't know if it's too low or too... Do I need to get closer from the microphone? Let me check here. Okay, and now we're gonna test this first to see if it works. For the pump, the way it is, I need to connect a jumper cable. So what we need is, like, when the relay is on, it needs to flow current through the motor with a 5-volt voltage. For that, let's see what we're gonna do. We're just gonna put, I can connect the pump. Let's improve this a little bit. Okay, let's see. I can put 5 volts on the pump. Here, closer. It's gonna go 5 volts, and it needs to go to the relay, and then the common of the relay needs to go to ground. Yes, I think that's it. So let's do this. I need to open this again, the 5-volt, and also insert also the 5 volts here. So I have choose connections to the 5-volt. Okay. Is it better if I do like this? I don't know. You guys can see a little bit wider. Let's see. And then this is gonna go to the first one. It actually needs to go to the open. Yes. I'm just gonna put here. We may need to change this depending of the side. I think it's this one that's gonna work fine. So the 5 volts gonna flow here, gonna go to the motor, and then it goes to the open side of the relay. And then the common goes to ground. Yes, that's what we need. Let me just get a small jumper cable. Yes. Then here. And this goes to ground. All right, I think everything is ready. Everything 20 minutes. And so the idea, I don't know if you guys have any questions, please ask. So we have the pump connected, we have the float, circuit, we have temperature sensor and soil moisture sensor. So that's everything we're gonna need on the hardware side for this. So let's go ahead and start putting some logic in this, right? I need my keyboard back. And we can okay, we can turn off screen. Okay, yes. And we're back. Okay, here. All right. So let me just move here, guys. You can see the electronics. You can see the pump. Yes. Okay. So the electronics is a little bit of mess here, but let's first test and see how everything's working. Let me take out the water from the pump from the water. I have the code already up and running on Balena. Start. Let me just. So the code is already done. What it does, it measures the soil. It measures the temperature and humidity. It puts all that information to an InfluxDB database, which then we have a Grafana that reads all this information and outputs as a very nice chart that we're going to display soon. And also we measure the soil moisture, and then if it's too dry, for example, it's going to turn the pump and the pump's going to water the plant. Pretty straightforward. I don't know if you guys have used Balena before. I have my device. I would encourage everyone to check it out. It's the best. It's a really good solution for you to manage your IoT devices. So I have my devices that I turned on before. It's a Raspberry Pi 2, and in the application I gave the name of plant. Okay, let's turn it on now. This way. Okay. As soon as I turn it on, the Raspberry Pi is going to connect to the Balena cloud, and it should display that it's on. Yeah, okay. Can clean, it's gonna start again, and it's gonna show us online. Instead of showing the code, actually, I want to show how to start a new. Imagine that you didn't have this project already downloaded. Let's go ahead and go to the GitHub page of Balena Playground. So if you guys already know Balena, we know we develop a lot of fun projects, a lot of example projects that we want for our users to check it out. And then here we have the balenaPlant. We call it balenaPlant Saver. Is the one that we're gonna work on today. Let me just go from scratch and show how it's gonna work. I already have the device working with Balena. If you didn't have that, I don't want to do it right now because it can take like a couple minutes, which is you create a new application. I can just show you how it would be, but I'm not going to do it right now. You would create a new application. I could call the name Plant Saver, for example. I would select the Raspberry Pi 2 in this case. I will create a new application and then add a new device. For that, all you need to do is select. I will go for development. Has a little bit, it's a bit different from the production environment. it's a little bit less open for development. There's all the information you can find in the website. You'd enter your Wi-Fi credentials, or if you're using Ethernet like I am right now, you can just close this. You download the image file, and then you burn the SD card with Balena Etcher. It's a very good software to flash not just Balena OSs, but all the Raspbian, for example. A lot of people use it. It's pretty good. The address is balena.io/etcher if you're interested to know. Right. Cool. So let's go ahead. Because I already have my device, which I call it Plant. You can see Plant, and it's already online. Oh, cool. Because I already have the software up and running, you can see the moisture is 0.8% because it's just on air. The temperature here is 26 degrees Celsius. Humidity 68.3%. It's pretty humid actually. I'm in Lisbon right now. And all the information that we can do. But let's pretend we didn't have this yet. We're gonna push the code from scratch. So what you're gonna do is go to the Balena GitHub project, click on clone with SSH, or you can even download the zip file. I'm just gonna clone it, and I'm just gonna decide to pay Plant. Okay, let's go to Plant. Let's see, I guess I can make it bigger for you to see better. Cool. So what do I have? I don't have anything here. I'm just gonna clone the project in this folder. Which it's gonna do is going to download our Docker Composer, because we have 3 Docker files, 3 Docker containers in this project. That's the best way we do, because we try to isolate each project in its own Docker Composer for security, for easier management, for example. Now I'm gonna open Visual Studio Code. I'm just going to open this folder. Find. You can see I'm also using Windows, but nowadays doesn't really matter, does it? Okay, so I downloaded the code to my machine. I have here 3 containers. I guess I can make these bigger as well. Cool. I have the Docker Composer, which configures the three Docker files that we have. And the one we're gonna take a look now is just the Plant Saver. I guess I can. There's a few more files. I can just delete. Okay, just make it a little bit more succinct. This is still like a development project. So this is like our Docker file, in which case we're using the Python 3 with the Raspbian Buster. And then those are we install these packages. We install packages, same thing as apt-get. And then you have the pip3. We're going to install all these Python libraries for our code. And then when our code starts, we have a class called Plant Saver, which actually interacts with all the sensors that we have right now. And then it prints the moisture, the temperature, the humidity status, water level. Pump count is a way that I decided to do, so it doesn't. It keeps reading every 10 seconds. it makes another reading of the sensor of the how moist is the soil. But the thing is, because of the water can take some time to penetrate the earth and spread, so I decided to just like, I keep reading, but if I turn on the pump for 10 seconds, it's going to wait a couple minutes before it read again. So it gives the water enough time to flow. So let's just push the code to the device, right? So a pretty cool thing, we have something called balena CLI. Before, I don't know if you guys used balena before, we used to push the code with Git, but now we have a much better application called balena CLI. It's gonna increase the AC because it's hot in Lisbon. Alright, let's see, what are we doing? Oh yeah, I just noticed that the title of this, it's wrong, of the stream. I'll just fix this real quick. Cool. Alright. No questions so far? So, what's gonna happen now? We have our three Docker composers, our three Docker containers. The balenaPlant saver, which gathers information from the sensors. We have the InfluxDB, which is just our database that we're going to store all the data that we're going to be measuring. And the Grafana, which is going to be the charts. The cool thing we're going to do is, let's push the code live. So all we need to do is, we need to go back and know what's the name of our application. It's called balena. Sorry, our application is called Plant. So all you need to do is balena push plant. Simple as that. We're going to start building all the images, and once it's done, it's going to update all the containers on the device. So all we need to do is wait a little bit. So here are our containers. So Grafana has 280 megabytes, InfluxDB 124, and the Plant Saver is 700. This because I'm using the Docker image that has everything installed. That's the thing that I usually do is you start with all the application, a lot of extra stuff that you probably won't need. And then once everything's working, you start refactoring the code, figuring out packages that you don't really need, and make the project slimmer. But that's something that you don't really need to worry right now. Okay, so actually, let's go back to the balena. Is it already done? Oh, that'll be fast. If you go here to the application, you can see the release hash B1F4. B1F4. Oh, actually, it's already up and running. Didn't need to wait anything, right? So all that happens is you press go, and it updates all the Plant Saver, the InfluxDB, and the Grafana. Let me just change the code just to see how it works. Let's say we have the word water level, and we can just hear water levels. Let's say we have multiple. We just want to make a change, and now we want to push the updates on our project. The cool thing is right now we only have one Raspberry Pi, but imagine that you were running this water measurement in 100 devices, 100 plants around your house or around the office, you name it. The cool thing is, like, once you change the code, you type balena push plant, and it's going to update the software in all your devices. And I think that's a pretty cool thing. Let's go back before it's too fast. You can see now it's downloading the changes on the container. And also the good thing is that we use something called Delta, which in this sense is going to only update one letter, so it should be super fast to update the code. And you can see like the images are being reinstalled. It's gonna restart. So yes, I'm just go quickly while this happens. Just want to show here real quick that the water levels, we just updated the code, and the log screen is every output that's happening on all the containers separately. So yes, so for the hardware, right now we are using a Raspberry Pi 2 connected to Ethernet and a power supply, but in the end the plan is to use a Raspberry Pi Zero. Okay, I'm using a capacitive soil moisture sensor. We have a DHT22 temperature and humidity sensor, and in the water pump. Also, of course, a flow switch, we call it. Okay, that's good. So it's measuring. The thing is, right now, because the moisture is very dry, it should be turning on the pump. Let me remember the code now, because I think pump count. It needs to run 1 minute. Let's see here. Pump false, pump count 1, pump on count 0. So pump count needs to be bigger than 6, and status code 1. I think this status code go back to the plant class. You guys can check all this code on GitHub as well. It's just a lot of functions that read each sensor, triggers the pump, for example, etc. And so we're gonna need probably to wait this to get to 6, pump count to 6, and then it should turn on the pump. Let's see what happens. Pump count. Just put like this, I can actually check the code again. Pump 5. Pump count, yeah. It's turning on. I don't know if you can see this. How can I do this? Can you see? I don't know. It's too small, I guess, right? You can see it's dripping here. Now it ran the pump for 20 seconds, and then it stopped. It's going to start counting again. It's going to start counting, and then it's going to start measuring the soil sensor. One thing that we need to do now, actually, the soil sensor is here, so that doesn't help much, right? We need to put this in the dirt. So what I want to do now, I want to let's just do this first. We can put the plant a little bit closer, and I'm gonna stick this sensor in the dirt. Now we can check the difference on the sensor. So it jumped from, I think it's moisture 27, from moisture 0 to moisture 27, which is pretty low. I think you can see it's getting higher because the water is penetrating dirt slowly. And this project also has Grafana, right? We haven't yet opened that. So one really cool thing of Balena is that in this screen you have all the information from your device. You can reboot the device, you can restart all the containers, restart containers separately, individually. I also added the moisture sensor and the status on this page. It's like, we call it tags. So you can see here now it's 28%. And if you want to check the device URL, it creates a VPN from the device that doesn't matter if it's behind Wi-Fi, it's behind 4G. You can always access the device if you want to. Before I show the Grafana, let's go back to the code a little bit. You can see the moisture is 28.2%. What that means is the soil is too dry, the pump is off, because I gave that time that the pump's gonna work actually once a minute. So if it's too dry and the count is 6 or more, it's going to turn on the pump. So let's, and the water is low because of my, I guess, okay, it's 6. Now I can see again, it's dripping. You can see that, right? I don't know if from the camera how it looks. Cool. So you can see now the soil moisture should start going up. And let's go to the Grafana. Let's see if it's working. You can even check in your computer if you want to. I'm gonna type this in the chat. So you have here the temperature and humidity. As you can see, the temperature is going low because I just turned on the AC in the office. You have the soil moisture was very low because it was on air. As soon as I put the soil moisture in the dirt, it showed here 28%. And then it got to a point that it turned on the pump. You can see this blue line here is the pump. And then you can see that the soil moisture is already at 61%. So that's a pretty cool thing, because then you can have this going through, like, you know, months. If you go traveling, you can just check how the device is looking, how everything is running. A cool thing that you can also do afterwards is just have a camera pointing to your plant if you want to check. We have a really cool project called balenaCam. So you can easily stream any image through a webcam using a Raspberry Pi and an old camera, webcam, for example. If you go back here now, you can see that the moisture here. The moisture is 60%, the temperature is 24, and then these are the three information that we have. It's like the soil is okay, the pump is off, and the water is low. Water is low because it's disconnected. Let's see, I'm gonna, if I put this down, which I'm like closing the circuit, it's gonna show water normal because I'm changing this. Let's go for the second part of this. I don't know if you guys have any questions meanwhile. So let's continue. Everything, you know, it's okay. It's on the Raspberry Pi here, but we need to make it a little bit better, right? Because it's using Raspberry Pi 2 instead of the 0 that we want. Okay, so let's figure out the things that we need to do. First thing, how are you going to put this water tank sensor? Because it's just 2 wires and this little plastic thing. And with that, I decided, okay, what do we need? We need to find a way to put this in the bottom of the tank where the water is going to push the sensor up, and then when the tank's empty, it's just going to go down. So with that, I decided to like, let's just 3D print a little support that I can just put this inside the water. And then I just want to show to you, this is the support that I had. So what's the idea? Oops. Oh, I guess you can see this. There you go. So this is the support that I decided to build. So you have the flow switch standing in the middle, and then you have the base. These 2 holes here I decided to use for putting something heavy that's gonna make sure that the support, the sensor is in the bottom. With that, I can show how it looks in the end. This camera is better. Right. I found 2 pieces of metal. I 3D printed the support, and this is pretty heavy. So now all you need to do is to screw this. Aha. So with the use of a 3D printer, we can have this inside the water tank. Right? So now if you go back to the Balena dashboard, you can see that the water is okay because this thing is inside the water tank and the switch is being pushed up because of the foam. And that's pretty good. That's one last thing that we need to worry about. The second thing is, okay, now the issue is that all this electronics is just very messy. Why don't we print a 3D case for that as well? Let's see, I have the plan, I have the project open here. Change the screen. First things first, we have the pump that we need to find a way to put it so it's not just in the table, right? Need to improve this a little bit. What else do we need? We need a Raspberry Pi 0. Okay. And then on top of the Raspberry Pi Zero, this one, we're gonna also have the hat. That's the hat. Are you guys being able to picture this? Now we need to build a case for it. Luckily I already did it. Doom. So the idea here is to screw the pump on the outside of the box. You have the Raspberry Pi Zero with the automation hat in the bottom. And I decided to even try adding a little hook where you can stick it to the side of the pot if you want to. I 3D printed a prototype for the side of the pot. It's here. Let's see, this was the first prototype, just to check if this would work well. But then I forgot, like, doesn't make sense, right? It falls. Okay. That will happen with prototyping, and then the second time I decided to make it a little bit deeper and a little bit slimmer. And then it works pretty okay. You can just put it here. So after that, I decided to print the case, which I already also have here, and I can show it to you. So let me, if you've seen in the 3D aspect, see if we can have this going here, right? One really cool thing of this, I have a Ender 3 printer, which it's a low-cost 3D printer that is actually pretty good. And one thing that got me super impressed is that it printed this hole here without any support. It happens that it bends a little bit because of it has a string of plastic that goes all the way from here to here. But then it worked fine, right? That's pretty cool. One technique that I like to use for screwing, because you have also the top. You have the top of the box. And then what I like to do is you have, you just melt the screws into the box with a soldering iron, and then after that all you need to do is put the second part on top and then put the screws through it, and it's going to get very secure, right? Let's see if it works. I haven't really tried yet. Aha, it works. If you want to like hide this behind the plant, for example, or you can just leave it on the table, that works as well. Yes, man. I really like watering the plants, but you know, if I can automate everything, that's what I would do. That's even more fun than actually watering the plants. So basically that's it. I will actually try to put everything from the electronics into this box. If you have any questions, please shoot. Otherwise, I'm just gonna take this apart and just hang out, listen to some music. Quick question: you can listen to the music, right? I think I configured the music to go and play, but I'm not sure. Yeah, let's hang out and let's put this thing together. So first thing I'm gonna do is see if I can put everything in this box. Where did I buy the sensors? So the automation hats is from Pimoroni. The moisture sensor you can get from Seed Studio. The pump is from Adafruit, and the soil moisture sensor, I don't remember right now, but if you just capacitive soil moisture sensor on Google, you can find some of the suppliers, places that sell it. But yeah, okay, so let's do this. What do I need to do? I'm gonna first turn off, and you guys can just hang out and enjoy. Let me just turn this off. I may need to unsolder some stuff now again. The thing is, like, the Raspberry Pi Zero, this one, it's a really nice piece of hardware, especially for the size. But of course, if you compare it with the with the Pi 3, for example, it's much slower, and it's also, but come on, it's $5, right? So what I'm gonna do is, because it takes some time to install, while we work on putting everything in the box, I'm just gonna leave the code uploading to this Raspberry Pi, so you guys can see how that goes in a second. I'll just fix the camera because it's here. Just gonna leave it here for now. Screen. Okay. So I have this Raspberry Pi. It's already connected to a application on the Balena cloud. I just need to figure out which one is it. I'm just gonna wait until it connects, then it's gonna pop up, because as you can see here, I have a lot of applications and tests and things that we built in the past. Plant. Let's restart this, reload the page, and see if anything changes. balenaPlant Pi 0, yes. Or isn't it? Is that the one? Oh yes. So I had the same hardware, actually the same code running on the Pi 0. If I want to change, you can see, for example, here we have water level, which is the old code, right? So what I need to do to update the code on this Raspberry Pi 0 is just get the balenaPlant Pi 0 name of the application, and similar way that we did before, let's just go balena push balenaPlant Pi 0. And with that, we're going to push our project, the latest version of our project, into this Raspberry Pi. So while this goes, let's go see how it works to put this box together. So I'm just gonna leave this going. Now we need to, let me see how it's gonna go. I'm just see what's the best camera for this. So we can have multiple angles of the same thing. A nice balena t-shirt. First thing I'm going to do is remove this hat. And I'm going to start with the Pump. Let's put the pump here. So everything's off. Let's unscrew the pump. Actually, I'm gonna leave the pump for last because I have it's already connected to the water and to the plant. So let's just leave this for last. Yeah, let's do that. So let's check the status of our Raspberry Pi, if the code is updated. Moisture 57, yeah, so our code in the Raspberry Pi Zero is already good to go. So let's go ahead and put the Raspberry Pi in the case. Let's see how this is gonna work. I made some holes in the bottom to hold the Raspberry Pi. So I'm just gonna use 2 holes for now, but then later, to save some time, then later I can just put the rest. It's a bit tight box. Let's see, should it go down or up? Okay, let's press 2 sides. By my calculations, this should work fine. Let's test if this actually fits in here first. Okay, wow, nice. Yes, so I guess we can just put the rest back. Where are you guys from? Kind of like that song from Pink Floyd, you know. Is there anybody out there? Oh, thanks for answering. So this is the first time I'm trying this, so let's hope it works. I don't need to like print another one. Oh yeah. This print takes like 5 hours. Oh, nice, Paris. I like Paris. I'm actually going to Paris in October. One second, that I need to find one thing. Okay, sorry. I had to get this. No. Okay, let's screw this. Get this. Now thinking, I wonder if it would be better just to the other way so you can put the screws in the bottom. Yeah, I'll do that because it's gonna be too much work. That's what happened when you're prototyping, right? Prototyping, learning on the go. Should get like a screwdriver, like electric screwdriver for this. Do you work with electronics as well, or just like a hobbyist? Let's see, this is actually too big, isn't it? It's gonna save us some time to do this. The smaller one I can use. I think this one's better. Have you tried using balena before? Give it a try. We have a lot of automation projects and things that you can do with just like a Raspberry Pi. Shouldn't be this hard. So how did you find out about the streaming today? nobody got time for this. So what we're gonna do is just because the holes are a little bit tight and the working space here is pretty tight, I'm just gonna make them a little bit bigger from the inside. And for that, I'm going to just use the solder iron. So what I do is just like, you just make the hole a little bit bigger. And that's it. So now it should be a bit easier as well. I think they're gonna look nicer if Thanks for coming. If you have any questions, just say anything on Twitter. Thanks, man. I'm just gonna be here geeking out with you guys. I'm just gonna be playing with electronics, do what I do, and make this thing happen. Thanks for coming. It was a pleasure. Alright. Sometimes something looks so simple, it's so annoying. Uh-huh. Okay, see? Show now. See, it's screwed here. Okay, let's just do one more side, and then that should be enough for this. Now we're cooking with fire. Boom. Nice. So now the Raspberry Pi is secured in the container. Let's go to the next step. Let's see, I need to put the sensor inside here. So there's something I need to unscrew. I'm just gonna remove first the, where's the screwdriver? So many things are all over this. This can go after. Remove the soil sensor here. So these are gonna go this way, so they can come to the side. Let's see here. This up a little bit. The joy of prototyping. It looks beautiful. Full of sand in my hands. So, because this is a prototype, then I decided to just keep all these holes open on the side because I didn't know what's going to happen. As you can see here, for example, you have these connections coming out to the side. I could also move the Raspberry Pi a little bit to the center so these connectors wouldn't be facing the side. They'll be more into the center, but that's something that usually, that's what prototyping is about, right? You need to test it and you need to see what's going to happen. Okay, let's move to the next step. So I guess, what do I have here? I have the sensor, then I need to connect the flow. Oh, let me try something. In this box, I actually installed a plan to install the temperature and humidity sensor outside. I wonder if I can actually do that. Let's see. There's only one way to try, right? With the joy of prototyping. Some water, that's good. Is this gonna work? Is this gonna go through? Let's see if this is gonna work. I actually don't know. I don't have the screws and they're way too small. Yeah, that's not gonna work. I think, do I have enough screws? No, I can leave this for later. It's not a major issue as well. But the important thing is that the hole is here, so then I just need to get the proper screws and I can screw into the box. That can be done later as well. the soil sensor. Now let's put the pump. That's the cool part. It looks pretty cool. I call this a good boom shakalaka moment. Let's see if this is big enough. Yeah, it's big enough. So let's do this. Let's see how I'm going to do it now. I'll find a way to do this. Oh, nice. I don't even need to force it too much. Side's done. I just need to put the bottom side here, and the pump is going to be secured in the box. All right. That's the best way to reach. It's kind of tricky. So this is pretty stable the way it is as well. Just leave this for now, and then screw that later. Like I said, this back. This is the ground, and this is the 5 volts. Okay, let's do this. And then I have the water pump. That's actually need to go with 5 volts. I can just connect that on the outside. Let's close that again. That is the 5 volts. Best thing is this is the first time I'm doing this live. You never know what's gonna happen. Okay, let's put this side. And these was in the open side of the relay. good. Should be very good. Is it? All right, so let's move on. So I just need now, that goes from the 5 volts onto the input. Yes. Because it's just a simple switch, doesn't matter which side I'm using. I need to unscrew the can. Okay, I guess I need to put the microphone a little bit closer. I don't know how. And then the other side is in them. Wait. Actually, because I don't want to move the pipes. This can go from, but then this one, yeah, I don't want to do this. Move everything forward. Fine. So I have these here. I have these here. And then I have this on this side here. So that should be enough then. Check. Alright, and the other side goes to input. What is input? Okay. Wow. Looks like everything is good now. Just try to organize this a little bit more. Isn't it the prettiest board we've ever seen? I don't need an answer for that. Imagine maybe just glue this for now here. Have some of the electronics, the circuits leaving. I'm just gonna put this back. This here. You have the water, you have the case. We need to close the case. I guess that's like one of the last things we need to do before we finish this. This is big enough, yes. Wow, look at this. Pro. Later I can glue this here. For now I'm just gonna leave it here. It doesn't matter. It's not gonna change anything. Let's put here, inside. So, let's see, we have the sensor. Oh, I guess I need to fix this a little bit. Here. Oh, look how pretty. Pump, water tank, plant, everything inside the case, right? All right, let's try turning it on. I guess that's the next step. Let's see if it's gonna actually work. You never know, right? Does my cable even reach? Yeah, it does. Oops. Now we can just wait for the plants to come online. So here in the dashboard it's still showing offline. So I can just wait a little bit. While that, I'm gonna get one thing here. Aha, now we're talking. So it should be online. That's what's going on. It's not working. Let's try pushing the code again. So the connections seem to be okay. Let's wait while this goes. You guys have any questions? Let's see what's happening. This is a really cool feature. You can just SSH into inside any of those containers. The problem is that the Pi0 is extremely slow sometimes. Okay, let's see, where did I put the code? source. You can check from here. Something wrong with the code now. It has to do with maybe the InfluxDB wasn't started yet. Let me just try restarting this. Now it's the fun part of the debugging. Source right. Oh yes, stopping it. Yeah, that's one of the reasons why I like to work with the Pi 0 instead of, that's one of the reasons why you work with the Raspberry Pi 2 and 3 and then you move to the 0. I didn't change anything. I think it was working before. Let's just wait for everything to update. Ugh. What do you think of the logo? Nice. Looks super cool, right? And everything inside the case. So it's gonna be perfect for Europe. Lisbon gets extremely hot in summer. So then if I decide to travel, I know that my plant's gonna be fine. Out of curiosity, this plant, it's called crouton. It's the name of the actual plant, like the type of plant. And the style and the name actually that I gave to the plant is crouton. You know, crouton, the crouton plant. That's the thing, like I'm working with the Pi 0, that's gonna take a long time to update this, but everything should be working fine. It was working before, and I don't think it makes a lot of sense to continue the stream while this just downloads. But I hope you guys enjoy it, learn something. Thanks for watching, and I'm really happy with the result that we have now. The balenaPlant working. And if you guys have any questions, I can share the link afterwards on Twitter, where you can actually check the status of my plant, because I plan to leave these on for a little bit. And thanks so much for watching, and if you guys have any questions, just tweet at us at balena_io on Twitter. And I'm also gonna upload these to YouTube later as well. Thank you. See you later.